Everyone, welcome to this video tutorial from Maths Paper 1 on Earth Geometry. So the scenario reads, the diagram below shows point A with 60 degrees north, 30 degrees west, B 30 degrees south, 30 degrees west, and C 30 degrees south, 75 degrees east. So this information has been illustrated in the diagram on the earth there. Then the question follows. If the local time at B is 15 hours, what is the local time at C? Then B, if it takes a plane 6 hours to fly from point A to B, what is speed in knots? Alright, so we are going to start answering this question. Start question by question 1. Let's analyze it. So they are saying that let's look at point B. So they are saying that if the local time on point B is 15 hours, this is point B. Then what is the local time at point C? This is our point C here. So these 2 points are on the same latitude to say. So B is due west of C. So for us to find time at C, we need first to find the difference in longitude between points B and C. So B is in the longitude 30. B is in the longitude 30. Then C is in the longitude 75. So B here is in the longitude 30. Then C is in the longitude 75. Since they are on different direction, we'll say that point B and C are on different directions. So therefore, we'll add the longitudes. So we'll say 30 plus 75. The value we are going to get is 30 plus 75 is going to get 30 plus 70 is 100 plus 5, so 105 degrees. This is the difference in longitude between point B and C. It's only when we know this information that we can answer this question effectively. So we should always know to say that 1 degree is equal to 4 minutes, but 15 degrees is equal to 1 hour, right? So if we use our formula to say that time is equal to theta divided by 15 degrees. Time, this now is, since we have used 15 minutes, we're calculating time in hours. So time is equal to theta we have is 105, which is the difference in longitude, 105 divided by 15. So if we divide 105 by 15, we are going to get our answer as 7. So this 7 we are calculating is 7 hours. Since we've calculated now the time using the longitudinal differences between B and C, we can say that we go to the points. B is east of C, and we say that as we go to it is west of C. So if we say that if we go to west, we lose time. If we go to east, we gain time. Since at B is 15 hours, then at C it means that we're going to add the 7 hours that we've calculated. These 7 hours because we are going to east, so we are gaining time. So if we say 15 hours, if we say 15 sorry, no putting of this to my sign for the signs for time, because this denotes a ratio. We just write 15 like that, then even add a 7 hours, 4 like that. So 15 plus 7, that's 22 hours. Therefore, time at C will be 22 hours. Then this will mean that we have tackled the first question. Now let's go to B. Let's go to question B. Okay. So B is saying if it takes a plane 6 hours to fly from A to B, what is its speed in knots? So let's write the formula. Distance is equal to speed over time. If we collect our data, or data rather, we will say we've been given hours, which is time, 6 hours. We want to calculate speed, which we don't know, and distance we can calculate from the scenario, right? So what do? We first calculate distance between these points A and B. After calculate distance, since we already have time, we are going to calculate speed from that. So for us to calculate distance between point A and B, we will say we'll go back. Point A and B are on the same longitude. Point A and B are on the same longitude, if you can see. Since they are on the same longitude, what we are going to do, we are going to find the difference in latitude. So the two latitude we have is A is on latitude 60, B is on latitude 30. So once we add these two latitudes, they are going to be our theta. Since they are on different sides, north and south, we are going to add. If they are going to be on the same side, we are going to subtract. But in this condition, we are going to add them. So our theta here is going to be 60 plus 30. This 60 here plus 30. So 60 plus 30 is going to give us 90 degrees. And use the formula for distance is equal to theta times distance is equal to theta times 60. So our distance is equal to theta found is 90 times 60. So distance is going to be 9 times 6 is 54. 54, then we even add these 2 zeros. So this is going to be our distance in nautical miles, because they want the speed in knots. So our distance won't be in kilometers, it will be in nautical miles. Since we found the distance, why don't you think we can calculate the speed? So speed is equal to distance times time. Now, our distance is 4,500 nautical miles times time, which is 6. That will be given. So here we can easily multiply this. 6 multiplied by 5 is 30. So say 6 multiplied by 0 is 0. 6 multiplied by 0 is 0. 6 multiplied by 4 is 24. 4 remainder 2. 6 multiplied by 5 is 30 plus 2, say 32. So our speed is going to be therefore 32,400 knots. That's how we solve this problem in paper 1 without using a calculator. Alright, thank you for watching. Stay tuned.